All right, we're going to look at finding the greatest common factor. Last time we looked at finding the least common multiple. In case you haven't seen much of this stuff before and all of those things, which is entirely possible, I can kind of pull back the curtain just a tiny titch and tell you that we're headed towards doing two different things. We're heading towards adding fractions with different denominators, and we're also heading towards reducing fractions. Okay, we've done reducing fractions a little bit. We're going to kind of, with this finding the greatest common factor, we're gonna look at a method for doing this if we have kind of larger numbers and reducing sort of larger numbers and those kind of things. So what we're going to do first in this is going to be probably the longest video we've had in a little bit. I think it'll still be a reasonable amount of time. But we're going to start by looking at something that you may have never seen before. In fact, it's very probable that you have never seen this before. We're going to look at finding a factor tree. Okay, so in order to do a factor tree, we're gonna kind of briefly make sure we understand the difference between two different types of numbers. That is composite numbers and prime numbers. Now this you may, probably not, but maybe have seen before, maybe, I don't know. I wouldn't stress if you've never seen any of the things in this particular video before. This may be the most new lesson we've done. This is kind of brand spanking new type stuff, and so don't freak out. We're gonna get lots of practice. If this doesn't click right away, don't stress. It's gonna be all right. So what is a composite number? A composite number is numbers like 8, numbers like 6, numbers like 33, okay? And prime numbers are numbers like 2. In fact, it's the only even prime number. 11, 7, all kinds of different numbers. Now, what does that mean? If you've never seen this, you may be thinking, there's no pattern. I'm confused. I'm scared. It's going to be okay. So composite numbers are numbers where they're factors. Now, what are factors? We talked last lesson about multiples. Factors are kind of the opposite. So multiples, remember, are like 8, 16, 24, etc., right? Those numbers. Those are multiples. Factors are what things can multiply to get a number. So like 8, we can split it up into 4 times 2, right? Or we can split it up into 8 times 1, right? We can split it up into 2 times 2 times, oh gosh, struggling, sorry. Slow down. That's a 2 times 2, right? Those things are all factors of 8. 8 can be split into those things. Now, what makes a number a prime number is the only thing, only factors of 2 are 2 times 1. The only factors of 11 are 11 times 1. The only factors of 7 are 7 times 1. Okay, so a prime number is a number where its only factors, this is not a factor tree, this is just an example. Its only factors are the number itself and 1. Okay, so to make a factor tree, we can also call this a prime. I changed my brush somehow. Let's change it to something that doesn't have that kind of dynamics. I don't even know how did I do that? I must have accidentally hit some sort of keyboard shortcut or something. A prime factor tree is also another name for this particular topic. So let's do a prime factor tree of the number 8. We kind of started it. Now, excuse me. Now, you would never start it with 8 and 1 because obviously 8 and 1. So it's got to be factors that are bigger than 1 because the 1's obvious. So what are two things that multiply to get 8? Well, two things that multiply to get 8 are 4 times 2, right? So now, in order to see for this factor tree, to see if we're done drawing this thing, we want to take a look at it and we want to say, okay, are these numbers prime numbers? So is 2 a prime number? If yes, then we're going to go ahead and circle it so we remember we're done with that branch. Okay, now is 4 a prime number? No, 4 is not a prime number, so we need to split it into factors. So 4 can be split into 2 times 2. Now, is 2 a prime number? We already said yes. And 2 is also a prime number. We're going to do a few examples of this. This is just the first easy one. So if you're freaking out, take your thinking cap, stick it on, and we're going to walk through these puzzle pieces. So the prime factorization of 8 would be 2 times 2 times 2. Now, where did that come from? All I did was write down the ones that we circled with times in between them. Okay, let's do another example of a factor tree. Factor tree. Let's do something slightly larger. How about let's do we're gonna demonstrate that they don't always look the same. And we're gonna do a factor tree of 36, but we're gonna do it twice. Okay, let's do a factor tree of 36. We're going to do it two different ways. Now, this is important, and this is kind of a scary place. Is the actual work on a factor tree may look different. The point is that you'll always get to the same circled numbers at the bottom. Okay, so what are some factors of 36? Well, you might see that 36 is divisible by 3. You might look at it and say that. Okay, so we might start there and say 3 times what equals 36. You can, of course, scratch paper these numbers if you want to with all these things. We need to, one of our next videos is going to be on divisibility rules, which may help us out with some of this. But you might be able to say, okay, 3 times 12 is 3 times 12 is 36. You might also take a look at this and you might know that, okay, all even numbers are divisible by 36. You might be, okay, it's even, right? And so it's definitely divisible by 2, right? And you might be like, okay, I don't know what 2 times what equals 36. So you might kind of go to your little scratch paper area and kind of do 2 into 36. 2 goes into 3 once. 1 times 2 is 2. You subtracted it, and then you put 1 and 16. 2 into 16 is 8. Okay, there we go. So you might be able to see that. And if you did that little scratch paper work, you might be able to split it into 2 and 18. So those are two ways to start this factor tree. Now you're going to notice in the end, we're going to get the same numbers. So let's go back to this one. 12 is pretty easy. There's several different options. You might look at 12 and say, okay, what goes into 12? Well, 6 and 2 does, 3 and 4 does. There are options, right? So we could split it into 2 and 6 would work just great. No big deal. No problem, right? And then I forgot to circle this 3, right? Because 3 is a prime number. So is 2. Now 6 we can split into 3 and 2. Now we've got all our prime factorization. Now I'm gonna rewrite these numbers just so that they match. I'm gonna write them in ascending order. So in other words, I'm gonna write these as 2 times 2 times 3 times 3 over here. So I just put the smallest ones on the bottom and the biggest ones on the top. You don't have to do that. I'm just doing it that way so that it'll match what we're doing when we write down the prime factorization over here. So if you did the 2 route, because even numbers, then you would look at 18. And you look at 18, okay, you might see, okay, that's another even one. I'm already thinking even, so maybe I realize, 2 times 9 is 18. Maybe I go that. You could also do 3 and 6, right? That would also also work. 2 times 9. I forgot to circle that this was a prime number. This one was also a prime number. Now 9 has 9 and 1 and 3 and 3. So that's really the only, we like ones that only have one option. That's nice. Makes our life way easier. Now the 3's, of course, are prime numbers. So this factors into 2 times 2 times 3 times 3. Now, so those factor trees, we're going to get some more practice with factor trees by doing examples of the title of this lesson, right? The title of this lesson was finding the greatest common factor. So let's do that. We're going to find the greatest common factor, or the GCF. GCF, greatest common factor, between, let's say, 18 and how about 50? And so the method we're going to use for doing this is we're going to start by doing a factor tree. Now there are different ways to do this, but I think a factor tree is a good way to start because it's very, very procedural. You kind of do the same sort of method every time. So 18, we'll factor out. We did 18 a minute ago, kind of as a subset of the bigger one, right? Let's pretend like we look at 18 and we love the number 6, and we realize, that we could split this into 6 and 3. And then 6, of course, splits into 3 times 2. So the prime factorization here would be 2 times 3 times 3. Right? So this is finished. Let's do 50. Now, 50 is kind of an easy place to start because it ends in a 0. We know. I'm going to move mine over. I don't think I left me enough space to factor tree this thing. There we go. Let's split this guy into 5 and 10, because 5 times 10 is 50. What about 10? That one's pretty easy too. Let's do 2 times 5. So this is completely factored. 5, 2, 5. Right? So 2 times 5 times 5. Now, what we want to look for next is, now that we've got these laid out, is we want to look for anything that's in common. So it's easy on this one because there's only one thing that's in common. Now we're going to make sure and do one in a minute where there's more than one thing, because that's going to be important to know what to do if there's more than one thing. But in this one, the only thing that's in common is 2. So the GCF between 18 and 50 is just 2. That's the only common factor. It's the only one that exists. Let's look at another example where if we have more things happening down at the bottom. We'll keep 18. Actually, we better do a brand new example. I was going to keep the same number, make our lives a little easier, but the more differenter examples we can do in this particular deal, the better, right? And so let's do, how about 56 and 24? I think that sounds like a great choice. All right, so let's take and split these. We're going to do factor trees of both, right? So for 56, you might know that 7 times 8 is 56. You might, if you don't know 7 times 8 is 56, you might do that little scratch paper trick, noting that it's even, and do a little 2 into 56 and get what that ends up, which would be 26. No, LOL, JK, it would be 25 plus 3 is 28. Right? You might get 28 times 2. That would be another way to start that one. 7 is prime. There's only things that go into 7 are 7 and 1. 8, we could split into 4 and 2. 2 is prime, so we're done with that branch. And then 4, of course, can be split into 2 times 2. Right? So let's list these out. 2 times 2 times 2 times 7. Okay, now let's see. I didn't give myself enough room again. Let's fix that problem. Maybe I'll learn eventually. Oops, wrong button. Let's split this guy into, how about 6 and 4? 6 times 4 equals 24 is a commonly known multiplication fact. So let's pop that one in there. 6, of course, can be, we've done that one several times. 6 can be split into 3 times 2, right? Those are both prime. 4 can be split into 2 times 2. Okay, so now let's list all these guys out. Excuse me. So now we've got a different puzzle piece, right? We've got something differenter happening. Because if we look at this list, we have more than one thing in common. We have, in fact, 3 whole 2s in common between these two. So 2 would be the least common factor, right? It's the smallest one that's in common between the two. But we want the greatest common factor. And so the greatest common factor would be all the ones that are in common multiplied together. So the last puzzle piece here would be 2 times 2 times 2, which of course is 8. So the greatest common factor between 56 and 24 is 8. We will practice this a bunch more in class and all of those things. Let me know how you're doing. I'll see you in class if you're one of my students. If you're not one of my students, hopefully this was helpful. If you have any questions, put them down in the comments below. If there's any clarifying bits we can add, I'd be happy to record some short videos and things to help you guys out as well. Thank you guys. Have a wonderful day. Don't forget to like, comment, and subscribe. Adios. Have a wonderful day. Bye-bye.